Everyone, welcome to Microcontroller and Embedded System Lab. In this video, we shall discuss program number 5, that is write a program to find the square of a number using a lookup table. So initially, we need to create a lookup table which contains the square of 0 to 10. Okay. This is our lookup table. It has the value of squares from 0 to 10. Okay, the square of 0 is 0, which is stored as 0. Next, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, okay, which is equal to hexadecimal 10. Then we have square of 5, that is 25, which is equivalent to 19 hexadecimal. Next we have is 36, square of 6, which is equal to equivalent 24 hexadecimal. Then we have 49, which is equal to hexadecimal 31. Likewise, square of 8 is 64, which is equal to 40 hexadecimal. Square of 9 is equal to 51 hexadecimal. Square of 10 is equal to 100, which is hexadecimal number 36. Okay, first before writing we need to create this lookup table to store our squared values. Okay, let us go to the program. Okay, initial steps are same. You have to create your project, then you have to select your microcontroller, then write the code, save it and check for error. If no error are present, you can debug it. Okay, how to by using this lookup table, how will we calculating the squared value? Okay, so to understand this concept, let us go. Okay, so now we have stored our squared values in some memory location. Okay, first we need to know the initial memory location, okay, where this first value is stored. Okay, if we know the initial memory location, we can get to know the next memory location. Okay, so first we shall debug the program and get to know the initial memory location. Okay, first line of code will say that load r naught with equal to table, which will load r naught with the initial address of your table. Okay, this initial address, that is where your 0 is stored, will be loaded to register r naught. Okay, so run this first step. Okay, so r naught is copied with the value 0x18. That means at this register value 0x18, we have the initial value 0x0. Okay, you can observe here it has 0. Okay, so same thing here, this 0 is stored at 0x18, or you can convert it to decimal value, which is 18 is equal to decimal 24. Okay, so next value, okay, that is 1, will be stored in a memory location which is equal to initial memory location plus 4. Okay, the next initial plus 4. Okay, initially we have 24 in decimal, the next memory location will be 28. You can convert it to hexadecimal if you require, that is 20 decimal 28 will be equal to hexadecimal 1c. Similarly, 4 will be stored at memory location 28 plus 4, that is 32. We can convert this to hexadecimal value. Or next memory location will be 36 and 16 will be stored at 40 memory location. 25 will be stored at 44 memory location. Next at 48. 60, and finally 100 will be stored at memory location 64. Okay, so now if I need to calculate 8 square, this is 8 square, that is equal to 64. Observe, for initial memory location I am adding 1 time 4, 2 times, 3 times, 4 times. Totally I need to add 8 times 4 to find the square of 8. Okay, so that is for initial value, if I add 8 times 4, I will get the address of, for initial value, if I add the 8 times 4, I will get the address of 8 square. Okay, similarly, if I want to find the square of 9, then I have to add 9 times 4. Okay, if I want to add, if I need to find the square of 5, then I have to add 5 times 4. Okay, this is the logic used to find the square of the required number. Okay, so how to execute this logic in your microcontroller? Okay, the line of code used to this particular line is this one. Okay, here initially observe R1 will be having the number whose square has to be found out. Okay, here I have to find the square of 6. Okay, R1 will be equal to 6 initially. Then I have to copy R1 with the value R1 comma LSL hashtag 0x2. What this will do is, this line will result in R1 into, okay, R1, so our register content R1 is multiplied with 2 to the power 2. Okay, so this particular line will result in the value R1 into 2 power 2. If I have 0x3, then it will result in the value which is equal to R1 into 2 power 3. How many times we are shifting logically, that has to be the power of 2. So here we required 4, so we are doing it as, we are shifting it 2 times, that will be equivalent to 2 square. Okay, this is the logic used to find the required address of our number. So now let us execute. So first we know the initial address of our table, that is 0x18. Then if you run, R1 will be loaded with 06. Next, after running the next line, that is R1 comma R1 LSL 0x2, the R1 value is changed to 0x18. Okay, that is in R1 we are having 6, which is multiplied with 4, which is equal to 24 in decimal. In hexadecimal it is 18, which is stored in R1. The next step is to add initial memory location and the memory location we have found out, that is 18 is added with initial memory location 18. Okay, and this memory, the result will be the memory location of square of 6. Okay, you can observe after running this. Okay, the R0 value, that is the memory location of our 6 square. You can search here, enter. Okay, then okay, this is 31, which is here you can observe here also, and it the same memory location value is copied to register R3, that is 31. Okay, 31 is nothing but the square of our decimal value 64. Okay. You can change the number and you can find the square of other numbers too. So to do that, debug, stop debug. Now I need to find the square root of 5, square of 5. So I am typing 5 here, build your program, then debug. Okay. First step, the initial value of our address is copied to or not. Then whose square has to be found out, that will be copied to R1. Execute. Okay. So R3 has the value that is square of 5. You can also observe this value in memory location 2C. It is 19. Okay, you can find any number between 0 to 10 using this table. If you want to find other squares, then you have to extend the lookup table to your requirement. Okay, this is all about the program number 5. Thank you.